Alright, today we are going to talk about chapter 4.3, 4.4, but before we get to those, we're going to talk about factoring the greatest common factor. So what we need to do is we need to understand what factoring is and how to factor a polynomial. Before we do that, let's think about what a greatest common factor is, a GCF. So remember, when we look at two different numbers, our GCF is the greatest number that goes into both of those. And the way we can figure out what the GCF is, well, we can make our prime factor tree of these numbers. So we can see what multiplies to 45. Well, 5 and 9 multiplies to 45, and then 3 and 3. And after I break it up, I always like to cross out the number besides the main number. Now I'm going to go do the same thing to 120. Well, what multiplies to get 120? Well, we get 5 and 24. Then we go here and we get 3 and 8. This splits up to 2 and 4, which splits up to 2 and 2. Now some teachers want you guys to rewrite these, so I'd rewrite this as 5 times 3 squared, and I'd write this next piece as 5 times 3 times 2 cubed. The reason it's 3 squared is because I have two 3's, and the reason it's 2 cubed is because I have 3 2's when I factor that out. Now when I multiply those, you guys, you'll get the same answer that you originally started with. Now really what I want to look for is I want to look for common numbers in my prime factor tree. So if you notice, I have a 5 here, I have a 5 there, I also have a 3 in each of those. And then my greatest common factor, all I do is I multiply those two pieces, so my GCF of these two numbers is 15. Alright, so now we need to do the same thing for our greatest common factor of polynomials. So really what we're going to do is we're going to look at each piece. Now this should be easy to do. You don't always have to make the factor tree. You only make the factor tree if you need to do that prime factor tree to see what it is. So when I look at these numbers here, or these polynomials here, I need to look at each piece of my polynomial, each monomial of my polynomial. So if I look at 3x and 12, I know I'm not going to be looking at the x's because neither or only one of them has an x, so I'm only going to look at the 3 and 12. Well, what's the greatest multiple that goes into 3 and 12? Well, it's 3. Now I'm going to pull that piece out of each of those. So what I mean there is I'm going to divide each of these by 3, because really I'm going to put that out front, in front of there. So when I do 3x divided by 3, well, that leaves 1x. And I do 12 divided by 3, I'm left with 4. Now really what we want is we're working backwards from expanding this out. Because if I expand this out, I'll get 3x plus 12. And that's how you check your answer. Did you get the right answer? Yeah, I did get the right answer. My actual answer is this piece. So let's try this again with 5x squared minus 15x. Now if you look at this one, we have two pieces we can look at. We need to look at our numbers, our coefficients. We also need to look at our x's. So first thing I'm going to do is look at my coefficients, and I can pull out a 5. That's kind of easy to see. Now my x squared, that's really the same thing as x times x. And if you guys didn't see it with this one, it's 3 times 5, so I can pull out a 5 in each piece there. All right, x times x, I can really pull out one of the x's. So I'm going to pull out that 1x. And what's going to be left on the inside is going to be, well, 5 divided by 5 is 1. X squared divided by x squared, or sorry, divided by x is going to be 1x left. And then it's going to be negative 3 is all that's left on that other piece, because I divided out a 5x from each piece. Let's look at this next one here. Look at the coefficients again. The biggest number I can pull out is 3. And if I have 3 x's and I have 2 x's, the most I can pull out are 2 x's. Now what's left inside is 2x plus, and now you got to make sure you put this part in there, because if I divide out a 3x squared and I do 3x squared divided by 3x squared, it's not 0. The biggest mistake kids will make on this one, or really anybody will make, is just doing that and calling it quits. But that's not the correct answer, because if I expand that out, all I have is 6x cubed. I need to make sure I put that what's left there is plus 1. Now when I distribute that through, I'm going to get 6x squared plus 3x squared. And that's what I want. So here's my answer. Now let's get a little bit trickier. We have to look, does each of our monomials within our polynomials, does each of our pieces have both coefficients and variables? Well, no. This last piece only has a coefficient. So that means the biggest thing I can pull out is a coefficient. Sorry, the only thing I can pull out is a coefficient. So look at 4, 12, and 8. What's the biggest number that goes into all of those? It's 4. Then I divide each piece out by 4. 4x squared divided by 4 is just x squared. Plus 12x divided by 4 is 3x. And negative 8 divided by 4 is negative 2. And there we go. All right, I have 5 problems up here I want you guys to try, and then I'm going to put up the answers shortly. All right, I want to talk about a couple of these really quickly. The first one in the red there pulled out a negative, and I always want to pull out a negative if my leading coefficient is a negative. I'm always going to pull out a negative number if I can pull out if I can pull out a number from each piece. So that's what I did with the red one and the blue one. You might have it a little bit different. I'd pull out the negative if I were you. Don't forget your ones on the blue and the green ones. And then if we look down here on the pinkish kind of one, nothing could get pulled out from each piece. None of them, 3, 7, and 21, don't have a like term that I can pull out. Greatest common factor. A to the 4th, well, that middle monomial doesn't have an A, so I can't do anything from any of them. And that first monomial doesn't have a B, so I can't pull out B from any of them. So that is I have no greatest common factor for those, so it would stay the same. All right, that's all I have for this video, so make sure you ask questions if you got them.